All right, guys, here is the final video for these problems. I'm going to knock out the last few sections in this one. So let's just jump right into it. Starting with 32, in this one, you see I just have a log on one side and not the other. And so this is one where I want to get the log by itself. So for me, in this problem, I would divide both sides by -8. And when I do that, I would get log base 9 of x equals -2. And now I'm going to do the little deal that turns a logarithmic equation into an exponential equation and say, okay, then 9 to the -2 equals x. And that's the same as 1 over 9 squared, and that's 1 over 81. And so there would be my answer to that problem. Notice before I did this little counterclockwise thing, I call it, I had to get the log all by itself. That rule said that just log base b of x equaled y if and only if b to the y equaled x. And so that didn't allow for anything out front. And so I had to get that -8 off there. Okay, taking that then into problem 34, which I have written down right here. First thing we're going to do is take away 6, so I'm going to isolate that log again. And in doing that, I get 2 log of 8n plus 4 equals, and 10 minus 6 is 4. Still don't have the log by itself because that 2 is still hanging out. So I'm going to divide both sides by 2, and I get log of 8n plus 4 equals 2. The big thing for you to remember is even though there's nothing down there, there's really a 10 down there. And if it was an ln down there, there would be an e down there, and I would say e to the 2 equals that. But since it's log, they mean it's base 10. And so in that case, I'm going to say, okay, well, 10 squared equals 8n plus 4. 10 squared is 100. 8n plus 4. If I take away 4, I get 96 is 8n. And when I divide by 8, I get 12. So that's how you would solve any of those problems in this section. All right, moving on to the next set of problems. In this, we're going to use a different property. So they call it the one-to-one property. I may have written it a couple days ago. Let's see. Well, here's where it originally is. These two properties right here. So we've been using this by when we take the log of both sides, and now we're going to exponentiate both sides. So I'll show you what I mean by that. Since it's true, and I'm going to write a few things here and then erase them. Since it's true that b to the log base b of x equals x, that means e to the ln of x equals x, or 10 to the log x equals x. In both of these secondary ones, I'm just using this with e there, and log base e is called ln. And if I put a 10 there and a 10 there, I don't need to put the 10 in the log. And so we're going to take advantage of the fact that when I have logs on both sides, if I take, most mathematicians I know call it e-ing both sides, but technically e-ing both sides would be that, taking it to the e. What we mean is e2. So I want to say e to the left side should equal e to the right side. And that's true because e is what's called a one-to-one function. So if I do that, then I'm going to say, and look, we're going to take advantage of that, that property right there, that the e and the ln once again kind of cancel each other out, so to speak. So in doing this, I'm going to say e to the ln of 10 minus 3x equals e to the ln of negative 4x. And now the e and the ln kind of wipe each other out, and whatever the x was on that side, 10 minus 3x, equals, on this side, it's negative 4x. So if I add 3x to both sides, we get 10 is negative x, so x is negative 10. So there you have that problem. And then in the second problem that I have for this section, number 38 there, notice I start with subtraction. So I don't want to 10 both sides right now. And we're not 10ing, we're not taking both sides to the 10th power. I'm taking 10 to the left side and 10 to the right side. The reason I don't want to do that right here is because then I have subtraction up in the power, and all I know for certain is that 10 to the single log x equals x. I don't know what 10 to the log x minus log y happens to be. So, since that's the case, I do know, though, that subtraction of logs is division. So, I'm going to say this is log of x plus 3 over x equals log of 74. Now I have just a single log on both sides. That log is the same log, it's base 10. And since that's the case, I am going to, and instead of writing it, I wrote it again there. I'm going to put the 10 down there and the 10 right there. And then I'm going to show that I'm aware that they cancel each other. And what I would be left with is x plus 3 over x equals 74. If I multiply the x over, I'll get x plus 3 is 74x. If I subtract x, I get 3 is 73x. And if I divide by 73, I get x is 3/37. In there, I think, yeah, in this, if I take log x plus 3 minus log x, so we have log x plus 3, x plus 3 minus log x. And on the other side, we had log, let's say y equals just 64, or log 64. So log of 64. All right, so what I have done here now is I have graphed this side as y equals that, and I graph this side as y equals that. Notice this is just a number, and y equals a number is a horizontal line at that number height for the y. So in there, and we got an answer of 3/37 for x. So I can tap here and see exactly where they cross. And they cross at 0.04762, it looks like, for that x value. But what I'm going to do is say this, x equals 3/73. That was the answer that we got. And you can see that, 3/73. Sorry, I got cut off there for a second. I'm going to paste these two back together. What happened was I had seen that, and here's the issue. I had a 64 there. And so what I needed to do was figure out why aren't those intersecting. It looks like a triangle there by the green, the blue, and the red piece. And it shouldn't be that way. And so I went to go back and look at our work, and it's a 74, which then if I change this to a 74, then they all intersect at exactly one spot, and that shows that that is the correct answer. So I'm just showing you a way that you can verify your answer even without looking in the back of the book. Obviously, you could do this also if I took 3/37 and I've already done it here. So I put 3/37 in right there. So it was stored in the answer. And then this side, that should be ants, and that should be ants, and you can see it right there. And that gave me a value of 1.86923171797. And then on the other side, I had the log of 74, and so I checked it right there. You can see those two values are the same, and so I have plugged it back in and used a calculator to check and verify my answer. That is checking it numerically, whereas this, we checked it graphically. And so I've graphed both sides of the equation as functions of y, and then we're looking if they're equal. That would be where are those two y values equal, and they are equal right there at 1.869. Notice in here, that's exactly what the last two answers on this calculator are, is 1.869, just like that shows right there, the y value. So that is how you would do that problem. Notice we need to get it simplified to just a log and a log before we exponentiate each side. So that's the thing to keep in mind. All right, the next set of problems, and this is the final set of problems here. I'm going to, let's see. I'm gonna, we'll do these. So in this one, the only difference in this, and I was just gonna sketch these for us. I see that I've got addition of logs. And addition of logs I know is multiplication. So I'm going to say log of x plus 12 should equal log of 12x, 12 times x. And I'm using the property that log of m times n is log of m plus log of n. And but I'm using it the other way to go from plus to multiplication inside. Now both of those are logs and both are base 10. So now instead of rewriting it, I'm just going to show it like that. Then I'm going to take 10 to the left side and set it equal to 10 to the right side. So in that case, the 10s and the logs cancel, and we get x plus 12 equals 12x. If I subtract x, I get 12 equals 11x. Divide by 11, and x is 12/11. And you can graph that or plug in the calculator and check and see. That gave me, so what gave me that idea to solve it that way? First of all, my x's are trapped inside the log. There's only one thing I know of that gets things out of a log, and that's b to a log b of x. Whatever's in there, that will get it out, and it'll bring it out onto the main line, and that's why we do this trick right in here. But in order to do that, I had to use the addition to multiplication rule in order to simplify this side to then get it into a single log and a single log. In this next problem, I have a log on one side and not a log on the other side, so I don't want to do, well, I'm going to show you something, even though I was about to stick my tongue in my mouth. I was going to say, here's the way I think about it. I instantly see this type of thing. And so I would want to say 2 to the 3 equals 7x plus 6. Now that I've said that, let's say 2 to the 3 equals 7x plus 6. What I started to say was I don't want to take 2 to each side because I don't have a log on this side. That's kind of a lie though, because, and why I don't want to do it is because for this reason, not for the reason that it's wrong or incorrect to do it. It's that I see this very quickly and can jump straight to that. To do it the other way, it's this. Since this is log 2, 2 to the log 2 of x would be x, because b to the log b of x is x. And if I take b to be 2, those will cancel. And so I'm going to then say, well, 2 to that side is 2 to that side. Or 2 to the log 2 of 7x plus 6 equals 2 to the 3. And then the 2 and the log 2 cancel. And so I would get 7x plus 6 equals 2 cubed. And lo and behold, that's what we had there. So when I said at first that I wouldn't want to do that, it wasn't because it was incorrect. It was because to me this is easier and I don't need to illustrate a step in between when I can just arrive there. Once I have that, then it's off to the races, really. So 2 cubed is 8, so we have 7x plus 6 is 8. Take away 6, we get 7x is 2, so x is 2/7. And in this final, this is one just like the one that we did right here. Notice it's a log minus a log, and so on this page, I have a log minus a log, and on the other side, we just had a log of 74. Now I've got a log of 58, and it's a different base. Yeah, here it was all base 10, but here it's all base 8. Big deal. The thing is, what I need to do first is turn this into division. So I'm going to say log base 8 of x. Oops, let me write that a little bit higher. X plus 6 over x equals log base 8 of 58. And now, since it is a single log and a single log, I want to 8 both sides. I call it 8ing, but really I'm taking 8 raised to the left side equals 8 raised to the right side. I'm going to write it though. So 8 to the log base 8 of x plus 6 over x equals log, or 8 to the log base 8 of 58. And then you can see those and those cancel. I get x plus 6 over x is 58. So x plus 6 is 58 x. Subtract 6 is 57x. So 6/57 is x. So there is that. And that should take you through. And as long as you study the properties of logs, and you did well with that homework, this homework should sort of be exciting because it's a chance for you to really do equations and solve equations using now new properties, and not just adding and subtracting, but you're using properties of logarithms to put things together and to make subtraction be division, and to exponentiate each side to get variables out of logs, to log both sides to get things inside, like over here. We took the ln of both sides, and same thing here. We took the log of each side to get them to cancel, and so on and so forth. So I hope that's enough, and it certainly should be enough assortment of problems that anything else in the homework that you encounter should be along the same lines. All right, take care, guys. Hang in there, and I'll be talking to you soon. All right, bye-bye.